Hi everyone, today we're building something like a snow animation in JavaFX. So normally you get to see various particle effects with snow that kind of create these words out of nothing pretty much. You'll see what I mean when I finish this. So we'll try that as a sort of basic as a start. And then if there is time, then I might just do some freestyle. I don't know. We'll see. Yeah, let's do the basics first, and then we'll see how this goes. As per usual, we need something on the screen, so we'll go from the usual stuff, if I can remember it. It's been a while. I should probably return a parent of some sort. Right, so we've got a root, which is, we need full control over the layout, so let's go with pane. 720p should do it. Now what do we need? Particles, so it's usually a graphics context on which we can draw, which is obtained from the canvas. And then let's construct the canvas over here. Again, these are the dimensions. Add the canvas to the root and make sure this graphics context is initialized. Right, so basics are done. What else do we need? We need a timer because we need to animate something. How's this? Implement methods. Yep, that's what we need. Don't forget to start the timer and then something like on update. That on update is called every tick, which in our world, since it's driven by the JavaFX animation timer, it will be driven by the refresh rate of the display by default. So if you have a 120 Hertz display refresh rate, that's the number of times this will be called. On update, we want to clear the context, which is that you probably want to extract these hard-coded values into variables. Now this will this is the template, I guess. Now onto the actual thing that we're going to do, because all of this stuff that doesn't require any thinking, because it's the same thing all the time. Let's think. We need snow. Snow is basically a particle and color white, and that should give us a start. Since it's a particle, it needs to have some kind of, it's called snow particle. It needs to have X and Y in terms of the position. We'll just assume it's 1 by 1 square particle, which will simplify things. In which case, if I can put them into a list of snow particles, then they are basically become something like, on update, clear the graphics context from the last frame, go through each particle, and then draw it on the screen. That should do it. And then obviously we need to update each particle on update. So we do something like P on update, and then we draw, fill rectangle, X, Y, and then width and height. Width and height are 1, 1. And then we can just take these X and Y. And then the color, I mean, there's nothing else that we're going to be drawing on the screen, so we might as well set it here somewhere to white. On update, what we want is to drop, so basically we want to apply gravity to each snow particle, and the way we do it is basically do something like this, right? I think it will look odd if it's exactly the same value for each. Will it look odd? Let's randomize this. Just to see if it's better. I think I've done something similar before, and having a randomized gravity works better because, you know, these are tiny particles. It's not like big objects that are falling from the sky. Next, int. How does this work? Uniformly distributed, good. No, I'm looking for the bound one. 0 is inclusive, the specified value is exclusive. That's all I need. So if I do 15, the maximum is 14. Let's go 10, so the maximum is 9. So basically this will give me a value between 0 and 9, and that's the value to be used to increment the y value of each particle on every frame. That is it, right? Like, we don't need to do anything else. We need to initialize all the particles. Let's extract this into something like num particles. 10,000 should do it. Particles, add new snow particle. We probably want some kind of initializer constructor thing going, right? In which case that becomes, so we want 0 for y because it's at the very top. For the x we want any value between 0 and 1280. So it's random next int bounded to 1280. And we know 1280 is not going to be returned because it's exclusive, so 1279 is the maximum value, which is good. It's within the bounds of the screen. Now we have particles, we are drawing them, and now here's the thing, if I spawn everything at once, which it currently does, we're just going to have a layer of them. We need a delay. How do we delay stuff? Now, if this was FXGL, it would be much easier. But JavaFX does not really have a built-in delay, I don't think. I guess we could kind of build an ad hoc one, like a duration. Thing, right? Because that would be the delay that would be set through the constructor to delay when to spawn the particle. Because after we spawned it, we don't really care because there's going to be an interval between them, so that's fine. But this initial delay needs to be there. On update, we don't do anything. Until the delay has passed, so each particle needs to keep track of its own internal time, which is 00 by default. And then when we update, this gets increased by something like this. This is hard-coded. You may wish to change that if you have a different refresh rate, different to 60 frames. And then if delay, can we get seconds? Yes. Is, let's do it the other way around. If t is greater or equal to seconds of the delay, then we can run. In other words, if we flip it this way, then we shouldn't run, right? So it's something like this. If t has not reached the delay, then we don't do anything with the particle. It is spawned, but it doesn't do anything. And then we need to pass in the something, the delay, duration, seconds. Hang on, what duration am I using? I'm using the wrong duration class. There's so many duration classes. I need the JavaFX one. There we go. Which doesn't have get seconds, but 2 seconds. Okay, I can work with that. In which case this goes, and the seconds. I guess I can do milliseconds, and then it's I multiplied by 100. Or something like that, because I is the index of each particle, right? So we can use that to offset each particle's spawn time. Maybe 100 is too much. Let's do 10. Okay, we've been going for a while, so let's see this actually do something. And then we can synchronize our mental model with our actual model. Well, for starters, the screen is white. And particles are white, so that won't work. We need something in there. Okay, so in which case we'll move that. Clear rectangle. In fact, we don't need to clear the rectangle if we're going to fill the rectangle with color black. And then we just reset it to color white to draw the particles. This isn't too bad. It does what it's supposed to do. I think it's quite jittery, that we can reduce the maximum gravity, which is this thing, between 0 and 9. What else do we want? So this is kind of the basics. The increased number of particles, reduce the delay, and you get more snow, less snow, or something like that. If you really want to make it fancy, try adding noise of some kind. Pull-in noise, simplex noise, anything will do, to kind of create this almost wind-like behavior. So these particles don't just fall down, they also kind of hang around in the air. Now, what else can we do? If we add text, let's go with that, because that's quite useful just in general, because people do these kind of animations where you see snow falling on text and kind of creating this outline of the text. Yeah, let's do that. Maybe reduce maximum gravity to something like 6 maybe. Right, so how do we draw something? The requirement is it has to be generic, meaning we can't just hard code it. So it has to, the text has to be modifiable. Static final string. I mean, we're kind of hard coding it, but the point is we can change the string to be anything that we want. And this could be something like message, the message that you want to do. I did something similar for the New Year message. I think we might do something implementation-wise similar as well. And that message could be something like hello world for now, and then you can replace it as necessary. Right. So there are various ways you can do this. Let's go with something that will give us reasonably good performance. I guess if we represent the entire screen, which is 1280 by 720, as a two-dimensional array, what I'm thinking is we can mark each cell if there is or if there should be a pixel in there. Because what I'm thinking is take a string, convert it into a user interface object, JavaFX text, use that to create a snapshot of pixels that it will occupy on the screen if drawn. But we don't actually draw it. We simply identify what the pixels are on the screen. And then these pixels can be kind of almost like bitmapped to a two-dimensional array. And then every time we update our particle, because a particle is basically a point, it has an x, it has y within that two-dimensional array. And if at any point it matches the text's position in that two-dimensional array, then we stop moving the particle. So it will just stop, it will fall on that text as if the rigidity of the text is blocking the snow particle from moving. So it'll create this kind of fake physics. In theory, it should work, but we'll see how it goes. So we need to be able to stop a particle from moving. Is moving. It's true by default, so it will fall. And if is moving, return. If not is moving, then don't update. Obviously draw it, but don't update. Okay, we have the ability to stop each particle from moving. Before we do that, two things. One, we need to obtain the pixels of this thing. Next step is to map it to the two-dimensional array, which we don't have. So let's get the array first. The array is, let's go for int array. I mean, we could use Boolean as false, true, false, nothing there, true, a pixel is there. But if I want to go further and add some other things, I think int might be useful. So this is basically our collision map, right? And the dimensions are the dimensions of the screen. By default, this will be initialized to zeros, which is good, which means there's nothing there. But then somewhere here, we need to text to pixels. How about that? I'll just extract this into a separate method. And then in this method, we are going to construct a JavaFX text, which is this. It's going to take the message, hello world. Then we're going to take a snapshot of it. The issue is I don't remember how to do this. Snapshot parameters and writable image. I think that one can be null, in which case a new image is going to be constructed. Parameters, image, it may be null. Okay, that's all I need to know. Snapshot parameters, what is this? I think I need to have snapshot parameters. Set fill. Color transparent. Is that rendering? Let's go with transparent because I want to capture the transparency, because if I'm taking a snapshot of the text as it is, it's going to take just the rectangle of it and give me basically a rectangle filled with color. I don't want that. I want just the pixels, and then all the transparent stuff goes away. So parameters and then null. That returns an image, which is a JavaFX image, which I should be able to get a pixel reader to read, get color of X and Y. That's, I think, is what I need, right? Because I can scan each row. So it's for image get height, and then for image get width, and then I get the color of it through the reader. And then this color represents that specific pixel. Now, where do I put these pixels? Is the question. So effectively, these are going to give me another two-dimensional array. Or I'll just use the collision map directly, because this text will be smaller in size than the screen, which is good. So it's collision map. Let's go for, so this is where the offset will be. This is kind of, we're almost like putting pixels to the screen without actually drawing anything. So I want to position the text in a way that is somewhere in the middle of the screen. Let's offset it by 300 in the x-axis and 300 in the y-axis, just to see what it does. And basically what we're checking for is if color equals color transparent, then don't do anything. So if not equals, then do something, which is that. That something is we set it to 1. So by default, two-dimensional array, all zeros. If we set it to 1, we're saying that there is a pixel there. And then all we need to do now is inside the update, we check if p.x.y inside collision map is 1, something like this, logically speaking. If it is, then we stop moving the particle because it collided with a pixel of the text that we wanted to draw. So I'll just stay there. One possible issue is that this y can go beyond. There's nothing that's stopping it from pushing beyond the bound of the screen. And now that we're accessing an array with that, that could be a problem because an array is fixed. It only has 720 elements vertically. So py needs to be stopped from going further than what we can do. So if it's equal to 720, which is the height of our application, of our screen, again, this should really be extracted. There's so many places that 720 and 1280 are used. Then we put it back to 0. That actually also kind of recycles the particle, right? Because if it falls through the screen, it just gets put back at the very top. And then what we might want to do, so that it doesn't just fall vertically all the time, it changes the x to this. So this will be pretty much an actual recycle of that particle. It will drop off the screen and it will be put back randomly in one of the positions. So it will create this snow effect all over again. Now we need to figure out this thing. I think it's as simple as this, really. Now let's see. Okay, so the particles are moving. The text, I don't actually know if the text is there or not. I'm not too sure this has done anything so far. How do we debug this? can we just set fill color blue, and then we'll just fill the rectangle, and then set white before we draw it. I want to see if the text actually got translated to pixels, and it actually probably hasn't done that because I can't see anything. So somewhere here there is a problem. Let's not do anything with snapshot parameters, and let's not do anything with these things either. Okay, how do I make the text bigger? Set font to 100. And then presumably this can also be null, so we don't actually change any of the default parameters. Just want a snapshot of the text. Okay, let's see if this prints anything. Does the text have to be within the scene graph for the snapshot to work? Okay, there is something which is doing something for each row and for each column, so that is fine. So this actually works. Collision map x plus 300, so that puts it 700-800 or something like that. And then y plus 300 is 1. Cool. And where was the drawing bit? For each particle, if collision map px py is 1, this is the position of the particle. Can we just draw the two-dimensional array first? This is 720 and this is 1280. That should draw the two-dimensional array and not worry about any of the particle stuff. I want to see where the text actually is. Okay, the text is here. So whenever the particle goes through any of that, it should stop moving. Now, how do I make the text transparency compliant? I think that originally should have done it. Cool. So we know that this part of code works. It takes the string, converts it to a UI object, converts it into pixels, and then puts the pixels into the two-dimensional array that we use to represent the screen, which is good. So whenever our snow particle collides with any of these pixels, the particle should stop moving. So it's that bit that we need to figure out. Good news is the more complex bit works. So it's just the easy bit that we need to figure out. of that is not needed. So if collision map px, py is equal to 1, which is something like this, p is moving. I don't think we need this either. Oh, it needs to be set to false. We don't want it to move. There we go. Now, this is going to give us the basics. The problem is the sides of the text that are kind of towards the bottom, they're never going to be outlined. Because if you think about it, the snow will just fall on top of the staff and it will be blocked as if it's a real kind of physics object blocking it, and it will never get to the bottom of it. So you may not actually see the entire word, the entire text. It can be fixed by allowing the snow particles to sometimes go through that layer, which could be quite interesting. So let's go ahead and do that. Which basically means if this thing is 1, and random next int between 0 and 10 is less than 9. That gives us a 10% chance, right? Yeah, hang on. Is greater than 8. Which is basically the other way of saying is equal to 9. Because next int of 10 will return a value between 0 and 9. It's 1 to 9 plus 0. There are 10 elements. We're looking for a very specific element, which is 9. So it's 1 out of 10 elements. These are uniformly distributed, therefore it's probably 1 over 10, therefore probably 10% chance. So 90% of the time, the particles will fall through the top layer every time they collide with the word. And that way we can get to see kind of the other bits of the text, which gives a bit more feasibility, I guess, of this approach. Because, you know, if it's an H, then it's very hard to see that it's an H, because you only get to see the top bit. Now, this is not too bad. I guess one last thing would be to kind of think about the distribution of the snow particles. Because what we could do, particularly if that slot is already occupied in the collision map, so I'm just thinking this X and Y, if it's already occupied, then can we kind of go up and then check if the pixel above it is not occupied? Because what I'm trying to do is basically kind of create like a stack, if you will, of snow. Now this is actually not bad. This is looking decent. And this is why I was interested in having this as an int array rather than Boolean, because what we could do is kind of represent 0 as empty, so there's nothing there, collidable, and then 2, snow. So snow particle is already there, which means if it's 1, then we could put a particle there, and we do, and this thing becomes a 2. Now the question is, when we next time hit it and it's a 2, so it's something like this. If it's a 2, then we do stop the thing from moving, but we also want to identify not the same pixel, but the pixel above it, so that we could place it there. And I'm hoping it's not going to look weird if we place all pixels kind of vertical, all snow particles vertically, because the randomness is uniformly distributed, meaning it's not just going to pick one column all the time. So this goes, but we need find next array position that is 1 or 0, because if it's 2, then a snow particle is there. And then how do we do that? Well, once we identify that, we need to move px, py to that position, so that the snow particle just kind of falls and then stays there. That is 1 or 0. Because we're just looking vertically, it's just, we just need to keep going with py, right? So while py is, because we're moving up, we only care about the lower bound, which is 0. So while it's greater or equal to 0, I suppose greater than 0, we don't really need to move if it's already equal to 0. Then py minus minus, which will shift it 1 pixel upwards, and then if this thing is 1 or 0, which basically means less than 2, if I don't want to do 2 if statements, then we're good, so we stop. Should it be something like this? And equals 2. While there is still margin and the current pixel is occupied by a snow particle, keep decrementing the y value. I think that's right. I can see a bug there, because even not moving particles get decremented and move upwards. But overall, I wonder if it actually works. I'll just do this. If it is not moving, then I'll try something like this. No, hang on, that might not be right. If is moving, Yeah, because this only needs to be checked if it's moving, because if we're not moving, then there's no point in checking. So the particles that stopped, they should no longer move. The particles that did not stop yet, they may move to the higher position. Well, for starters, this is moving really slowly, so I can't actually see, plus we don't have that many particles anyway. Let's make it 25,000 or 52,000, that'll do too. And let's make it move fast. As long as we can actually handle drawing so many particles. So what we're looking for is the fact that they stack up. They should create a thicker outline towards the top, but I can't actually visibly see that. I think it's doing it to some extent, but there's something that's missing or blocking it. I suspect it's this random thing, because even if it does match, it will try only 10% of the time, which we only want to do for the initial, I think. Maybe. I don't know. Let's see how this one does. Maybe. What if we do it all of the time? So this will go back to us not seeing the bottom bits of the word, but at least we get to see how they stack up. Yeah, so I think we're now getting a much thicker outline towards the top, which will work only in some cases, I guess. Like with the H, it's very difficult because you don't get the sides of it and not the bottom. But if you add some variation along the x-axis, because currently it's just moving top to bottom, right? There's no variable change in the x-axis. With something like Perlin noise, I think this could be really a nice effect. But even without it, this almost like creates a 3D outline of the text, which is kind of fun. Okay, I think I will stop on that note. We've looked at a range of ways to outline text, which is arbitrary as well. You can just change the string over there at the top of your application source code, and it will be that text that will get outlined with kind of snow particles. And depending on how you want it to behave, you can play around with things like the gravity, or the thing that you use in order to move each particle from top to bottom, as well as if you want to introduce any change in the x-axis, which can make things a bit interesting. Like if you add wind, and then that will act as a force applied to every single particle. Or if you want to kind of introduce a locality, that's even better. Some particles will be affected more than other particles. In any case, you have a range of improvements that you can apply on this application. And I'll upload the source code in a minute. On that note, thanks for watching. I'll see you later. Bye-bye.